Bismillahirrahmanirrahim. In the name of Allah, the most gracious, the most merciful. Be the change that you wish to see in the world. Today, the topic of my presentation is kruskal wallis test, and I will be presenting it under the supervision of Professor Dr. Saira Afzal. Learning outlines, non-parametric tests and their types, definition of kruskal wallis test, hypothesis and assumptions, formula, procedure, examples, recent advances, and MCQs. Learning objectives. At the end of the presentation, participants will be able to describe the kruskal wallis test, its correct use, assumptions, and overall procedure. What are the non-parametric tests? Parametric tests are statistical tests for population parameters such as means, variances, and proportion that involve assumptions about the population from which the samples were selected. One assumption is that these populations are normally distributed. But what if the population in a particular hypothesis testing situation is not normally distributed? Statisticians have developed a branch of statistics known as the non-parametric statistics or distribution-free statistics to use when the population from which the samples are selected is not normally distributed. Non-parametric statistics can also be used to test hypotheses that do not involve specific population parameters such as mu's, sigma, and p. They are used to test the hypothesis about population parameters when the assumptions about normality cannot be met. Non-parametric tests and statistics can be used in place of their parametric counterparts when the assumptions of normality cannot be met. As you can see, these are the alternative non-parametric tests which can be used for the parametric tests. Paired t-test, Wilcoxon signed rank test, unpaired t-test, Mann-Whitney U-test, one-way ANOVA, Kruskal-Wallis H-test, and Pearson's coefficient, Spearman's coefficient. Advantages. They can be used to test population parameters when the variable is not normally distributed. They can be used when the data are nominal or ordinal. They can be used to test the hypotheses that do not involve population parameters. In some cases, the computations are easier than those for the parametric counterparts. They are easy to understand. There are fewer assumptions that have to be met, and they are easier to verify. Disadvantages. They are less sensitive than their parametric counterparts when the assumptions of the parametric methods are met. Therefore, large differences are needed before the null hypothesis can be rejected. They tend to use less information than the parametric tests. For example, the sign test requires the researcher to determine only whether the data values are above or below the median and not how much above or below the median each value is. They are less efficient than their parametric counterparts when the assumptions of the parametric methods are met. That is, larger sample sizes are needed to overcome the loss of information. For example, the non-parametric sign test is about 60% as efficient as its parametric counterpart, the z-test. Thus, a sample size of 100 is needed to use for the sign test compared with a sample size of 60 for use of the z-test to obtain the same results. Kruskal-Wallis test. The analysis of variance uses the F-test to compare the means of 3 or more population. The assumptions for the ANOVA test are that the population are normally distributed and the population variances are equal. When these assumptions cannot be met, the non-parametric Kruskal-Wallis test, sometimes called the H-test, can be used to compare 3 or more means. It is sometimes called the one-way ANOVA on ranks, as the ranks of the data values are used in the test rather than the actual data points. Hypothesis. The test determines whether the medians of 2 or more groups are different. Like most statistical tests, you calculate a test statistics and compare it to a distribution cutoff point. The test statistic used in this test is called the H statistics. The hypothesis for the test are HO null hypothesis assumes that the samples are from identical populations. H1 alternative hypothesis assumes that at least one of the sample comes from a different population than the others. The Kruskal-Wallis test will tell you if there is a significant difference between the groups. However, it won't tell you which groups are different. For that, you need to run a post hoc test. Assumptions. There are at least 3 random samples. Should use ordinal scale, ratio scale, or interval scale dependent variables. All groups should have the same shape distribution. One independent variable with 3 or more levels. The test is more commonly used when you have 3 or more levels. For 2 levels, consider using the Mann-Whitney test. Examples. You want to find out how test anxiety affects actual test scores. The independent variable test anxiety has three levels: no anxiety, low, medium anxiety, and high anxiety. The dependent variable is the exam score rated from 0 to 100%. Number two, you want to find out how socioeconomic status affects attitude towards sales tax increases. Your independent variable is the socioeconomic status with three levels: working class, middle class, and wealthy. The dependent variable is measured on a 5-point Likert scale from strongly agree to strongly disagree. Formula. In this situation, the distribution can be approximated by the chi-square distribution with k minus 1 degrees of freedom, where k is equal to number of groups if the number of observations in each group is 5 or more. The test also uses ranks. In the Kruskal-Wallis test, you considered all the data values as a group and then rank them. Next, the ranks are separated and the H formula is computed. This formula approximates the variance of the ranks. If the samples are from different populations, the sum of the ranks will be different and the H value will be large. Hence, the null hypothesis will be rejected if the H value is large enough. If the samples are from the same population, the sum of ranks will be approximately the same and H value will be small. Therefore, the null hypothesis will not be rejected. This test is always a right tail test. The chi-square table G with degrees of freedom k minus 1 should be used for the critical values. Since the test is a right tail test, the null hypothesis will be rejected if the test value is greater than or equal to the critical value. Formula for the Kruskal-Wallis test. This is the formula we use for calculating the H statistic. H is equal to 12 over n plus 1. R1 square over n1 plus R2 square plus n2 plus Rk square over nk square minus 3n plus 1. R1 is the sum of ranks of sample 1, n1 is the size of sample 1, R2 is the sum of ranks of sample 2, n2 is the size of sample 2, Rk is the sum of ranks of sample k, and nk is the size of sample k. N is equal to n1, n2, and nk, and k is equal to the number of samples. The procedure for the Kruskal-Wallis test: step 1, state the hypothesis and identify the claim. Find the critical value. Use the chi-square table G with degrees of freedom k minus 1, k is equal to the number of group. Step 3 is computing the test value. Arrange the data from the lowest to the highest and rank each value. Find the sum of ranks of each group. Then you have to substitute this in the formula. The formula which was shown previously is given there as follows, where n is equal to n1, n2, and nk, rk is equal to sum of ranks for the kth group, and k is equal to number of groups. Step 4 is making the decision, and step 5 is to summarize the results. There's an example given. A researcher wishes to see if the total number of infections that occurred in 3 groups of hospitals is the same. The data are shown in the table. At alpha 0.05, is there enough evidence to reject the claim that the number of infections in 3 groups of hospitals is the same? Group A, Group B, and Group C. The data is given as follows. Solution. So in step 1, we will state the hypothesis and identify the claim. And there is no difference in the number of infections in 3 groups of hospitals. That is our claim. Alternative hypothesis is that there is a difference in the number of infections in 3 groups of hospitals. Step 2 is finding the critical values. We will be using the chi-square table with degrees of freedom k minus 1, where k is equal to the number of groups, with alpha is equal to 0.05 and degrees of freedom 3 minus 1 is equal to 2. The critical value is 5.991. As you know, k is equals to 3, as there are 3 groups of hospitals which are given. Step 3 is compute the test value. Arrange the data from the lowest value to the highest value and rank each value. Find the sum of ranks for each group. Group A. The data is ranked from the lowest to the highest value in this. Then the ranks are given to the data. Then we will find the sum of ranks for each group. Group A, Group B, Group C. We will calculate the sum of ranks. Then we will substitute them in the formula which is given below. Therefore, substituting the values in this formula, we calculated 5.346. Step 4 is to make the decision. Since 5.346 is less than our critical value, which was 5.991, the decision is not to reject the null hypothesis. Stepwise is summarizing the results. There is not enough evidence to reject the claim that there is no difference in the number of infections in the group of hospitals. Hence, the differences are not significant at alpha 0.05. Now, these are the recent advances and examples from the literature. Alternate forms of the one-way ANOVA F and kruskal-wallis test statistics. Abstract. For ease of instruction in the classroom, the one-way analysis of variance F statistics is rewritten in terms of pairwise differences in individual sample means instead of differences of individual sample means from the overall sample mean. Likewise, the kruskal-wallis test statistics may be rewritten in terms of pairwise differences in individual average ranks rather than the differences of the individual average ranks from the overall average rank. In unbalanced design, it is seen that the contribution to either test statistics from a pair of samples is related to the product of sample sizes multiplied by the square of the relevant pairwise difference. Supplementary materials for this article are available online. Analysis of the COVID-19 data using the neutrosphobic kruskal-wallis edge test. Abstract. Background. Kruskal-wallis edge test from the Bank of Classical Statistics test is a well-known non-parametric alternative to a one-way analysis of variance. This test is extensively used in decision-making problems where one has to compare the equality of several means when the observations are in exact form. The test is helpless when the data is in an interval form and has some indeterminacy. Methods. The interval value data often contain uncertainty and imprecision and often arise from situations that contain vagueness and ambiguity. In this research, a modified form of the kruskal-wallis edge test has been proposed for indeterminacy data. A comprehensive theoretical methodology with an application and implementation of the test has been proposed in this research. The proposed test is applied on a COVID-19 dataset for application purposes. The study results suggested that the proposed modified kruskal-wallis edge test is more suitable in interval value data situation. The application of this new neutrosphobic kruskal-wallis test on the COVID-19 dataset showed that the proposed test provides more relevant and adequate results. The data representing the daily ICU occupancy by the COVID-19 patients were recorded for both determinate and indeterminate paths. The existing non-parametric kruskal-wallis edge test under classical statistics should have been given misleading results. The proposed test showed that the 1% level of significance, there is statistically significant difference among the average daily ICU occupancy by corona-positive patients of different age groups. The findings of the results suggested that our proposed modified form of the kruskal-wallis is appropriate in place of the classical forms of the test in the presence of the neutrosphobic environment. There's another article, fatty acid transfer from blood to milk is disrupted in mothers with low milk production, obesity, and inflammation. In the background, obesity is associated with chronic inflammation and is a risk factor for insufficient milk production. Inflammation-mediated suppression of LPL could inhibit mammary uptake of long-chain fatty acids. In an ancillary case control analysis, we investigated whether women with low milk production despite regular breast emptying have elevated inflammation and disrupted transfers of series from plasmas into milk. Methods. In the methods, they have used the assessed by linear regression methods, chi-square exact tests, and kruskal-wallis non-parametric tests. And in the conclusion, mothers with very low milk production have significantly higher obesity and inflammatory biomarkers, lower LCFs in milk, and disrupted association between plasmas and milk. These data support the hypothesis that inflammation disrupts normal mammary gland fatty acid uptake. Further research should address the impacts of inflammation and obesity on mammary fatty acid uptake for milk production. Now we head on to our MCQs. Number 1, the kruskal-wallis test uses which distribution? A, chi-square, B, Z, C, T, D, F, and E, X. Yes, A is the right answer. Which test is used to determine if a relationship exists between a race, white, black, Asian, and satisfaction with the economy on a scale of 1 to 10, where 1 extremely unhappy and 10 is extremely happy? Satisfaction is not normally distributed and N is equal to 47. A, one-way ANOVA, B, kruskal-wallis test, C, Mann-Whitney U test, D, independent sample D test, and Chi-square test.
B.
Yes, B is the right answer. In the kruskal-wallis test of K samples, the appropriate number of degrees of freedom is A K, B n minus K, C K minus 1, D n, E is equal to 1.
B.
No, C is the right answer. You are doing research for an article on the waterfalls on our planet. You want to make a statement about the height of the waterfalls on three continents. Three random samples of waterfall heights in feet are shown. What will be the corresponding parametric test? A z-test, B independent t-test, C dependent t-test, D ANOVA, E Pearson's coefficient.
D.
Yes, D is the right answer. You are doing research for an article on the waterfalls on our planet. You want to make a statement about the height of waterfalls on three continents. Three random samples of waterfall heights in feet are shown. For a significance level 0.05 and critical value 5.991, compute the H value. A 0.05, B 0.01, C 0.09, D 0.07, and E 0.04. Anyone like to answer? Okay, we will substitute these values in this formula for calculating the H statistic. And by substituting the values, we will get 0.01. So in this MCQ, B will be the right answer. The kruskal-wallis test is used when you have at least ordinal scale dependent variables and one independent variable with three or more levels. For two or more levels, we considered using which test? A Mann-Whitney U test, B Friedman test, C ANOVA, D sign test, and E is the H test. Am I audible?
Alpha.
Yes, A is the right answer. A researcher tests three different brands of breakfast drinks to see how many milliequivalents potassium per quart each contains. The data obtained is shown at alpha 0.05 and critical value 5.991. When will be the null hypothesis rejected? A, H value smaller than the critical value, H value greater than the critical value, H value equal to the critical value, H value equal to 0, H value equal to 1.
A.
No, B is the right answer. H value greater than the critical value. Compared to parametric methods, the non-parametric counterparts are A less efficient, B more efficient, C more sensitive, D more informative, E more difficult to understand.
Alpha.
E is the right answer, less sensitive. Three random brands of coffee are rated for taste on a scale of 1 to 10. 6 persons are asked to rate each brand so that there is a total of 18 observations. The appropriate test to determine if three brands taste equally good is one-way analysis of variance, Spearman rank of difference, Wilcoxon rank sum test, kruskal-wallis test, E-sign test.
D.
D is the right answer. A researcher wants to know whether or not three drugs have different effects on knee pain, so he recruits 30 individuals who experience similar knee pain and randomly splits them into three groups to receive either drug 1, drug 2, or drug 3. The following is an example of kruskal-wallis test, which is A right tail test, B left tail test, two tail test, no tail test, and multiple tail test.
C.
No, A is the right answer. The kruskal-wallis test is always a right tail test. This is the key of our MCQs. Thank you. And this is the link of our YouTube channel.
Thank you very much, Dr. Alishba. Very nice presentation and very well delivered. The most important thing is, yes, you have worked very hard, especially on MCQs. I hope everyone has learned a lot today. Thank you very much. Allah Hafiz.
Thank you, ma'am. Thank you so much. Good job.